Good morning, Ben Cohn from benkphysics.com. Hope you're doing well today. The resultant of the two vectors, A and B, possibly alpha and bravo, don't know, maybe, of magnitude 6 and 10 respectively, so A is 6, B is 10, is at right angles to vector A. Find the resultant vector and also the angle between the vectors. Okay, we can do this. So I am going to start by drawing A. Just line thickness, bigger. There we go. Oh, that's much better, A. Up. There we go. Back to pencil. That's very demanding. Okay, so we have an A there. We'll have, what I'm going to do then is I'm going to draw a circle. Your first thought is, well, that's a terrible circle. It's all oblong and such. Ovally. Well, it is, because there's perspective. So this here, I'm going to say is a right angle. Right angle between A and the circle. And so then what B is going to be, we'll go to purple, and then we'll draw another line, and we'll go like this. There we go. I am surprisingly happy with that. So not sure if, there we go, a little bit smaller. So what this is saying here is that when we add A and B together, the way you add vectors is tip to tail. Then the resultant vector, vector C, I guess I need another color now. Ooh, green. C is at a right angle to A. So when you're talking about 3 dimensions here, that right angle will become a circle. So anywhere, this A plus B will be anywhere on this circle, which is fine with us. So even though I chose B to go to the top, I could have chosen anywhere. It could have been to this, well, not anywhere, but anywhere on the circle. Could have been on the sides, bottom, et cetera, et cetera. Okay, so now let's plug in some of the data that we have. Ooh, light blue. Find the resultant and also, okay, so this is 6 and 10 magnitude. So find the resultant and also angle between the vectors. Okay, so the resultant is going to be C. And so we want to find the length of C. Now, if you notice here, this creates a right triangle. So what we can do with this then is Pythagorean theorem. Pythagorean theorem? Pythagorean. Maybe. Not sure. So we have, I'm going to rewrite that a little bit. I'm going to say instead here, so we know this side squared plus that side squared equals that squared. So I'm going to say A squared plus C squared equals B squared. I know you're normally used to A squared plus B squared equals C squared. They're just variables. We can mix them up. It's okay. No need to panic, at least not yet. All right, so then we know A, it'll be 36, which is 6 squared. Then we'll have C squared, which will be C squared. And then B squared, which will be 10 squared, which will be 100. That's not a very good 100. There we go. And so C squared equals 100 minus 36, which is 64, which implies that C equals 8. And normally it'd have to be like, well, positive 8, negative 8. It's okay. We're dealing with vector lengths here, so just magnitudes. So we'll go with a positive of positive 8. Okay, so we know that C is going to be 8 because right angles, triangles, and such. If you notice, this is similar to a 3, 4, 5 triangle, which you're like, what's a 3, 4, 5 triangle? Well, a lot of times you'll see that triangles 3, 4, and 5 kind of work out together. And this is just that doubled. Okay, back on track. Let's find some angles here. So we find the resultant and also between the vectors. Okay, so we're going to find the angles here. So I'm going to say angle. I'm going to do this a little bit differently. I'm going to say theta. Theta. This is A. That is B. So I'll do theta AC. So this angle right here. That's going to be easy. That's why I did that one first. It'll be 90. Or if you like radians, we'll say pi over 2. Theta. Then the next one would be theta up here, BC. We're going to do this one instead. Theta angle AB. And that will be, we'll use trigonometric rules. So we have SOHCAHTOA. SOHCAHTOA. And for this one, we'll use cosine. Though we know all the angles, so we could use different ones. Cosine of theta, adjacent over hypotenuse, would be 6 over 10. So to find theta, AB, we'd do arc cosine of, I'm going to say 3/5, but that's just 6/10 reduced. And for this, I'm going to use Wolfram. Come on, Wolfram. Arc cosine of 3 over 5. There we go. And we get 53 degrees. So for this, we have 53 degrees. And then to find the last angle if we wanted to, we know that sum of all angles add up to 180 for a triangle. So we do 180 minus 90, which would be 90. So theta BC would be about 47. Is that right? 37. 37? 37. Because 37 plus, yep, so all these in would equal up to 180. So that's how you look at this problem. A little bit fun with vectors and angles and trigonometry, but overall, pretty good problem. Thanks for asking.